Okay, let's start. Today our lecture all about loss minimization interpretations. So in previous 7th lecture in the series of logistic regressions, we already discussed the geometric interpretations and the probabilistic interpretations. We discussed the geometric interpretations briefly. Geometric interpretations, we discussed it briefly. Okay. In brief we discuss, and probabilistic interpretations we give some pointers where you can learn in brief and it is discussed in detail. Okay, I think if you have any problem you can just comment it. I am trying to solve your problem. Sorry, Logistic. Okay, we have already done these two things. Now in today's lecture we applying the loss minimization functions. Okay, in today we have applied the loss minimization functions to interpret the logistic regressions. Okay, so first remember what is our optimization equations. In previous class we have learned our mathematical optimization function. Just first write down it. What is our mathematical optimization function? That is optimal W, which is coming from our arc mean of W summation I is equals to 1 to n log of 1 plus exponential minus yi w transpose x. And we also called the sign distance as zeta, that is yi w transpose xi. Okay, which some books which is written by yi functions of xi. Okay, where functions f of xi is equals to w transpose xi. Why this function, why they have taken w transpose xi as a functions? Because these functions determines whether this the point is positive class or negative class. These points actually determines. So this function determines what the point is positive class or it is a negative class. It determines whether it is in positive or negative class. Okay, so for this reason we have taken w transpose xi as a function f of xi. Okay, till now we have learned in previous lectures. Now in ideal optimization model, what we have is, if we just write down in language what we learn in ideal optimization problem, what we know in ideal optimization problem, just write down ideal optimization problem. Okay, so ideal optimization is what? Ideal nothing. It is just we have to find the W star where we want to minimize our number of incorrect classified point. Okay, this is the main every classification. The main goal of every classification problem is we have to optimize the minimum number of classification point. This is the main ideal optimization model. So just write down it. Argument arc mean of what? Over all W we have to minimize number of incorrectly classified point. Correctly classified point. Okay, this is the main object. Now suppose let's take that +1 is, we have denoted the +1 for incorrectly classified point and 0 for correctly classified. Suppose let +1 for incorrectly classified, classified point, and let's take 0 for correctly classified point. Okay, so we want to minimize our loss as well as maximize our profit. Means what? We have to minimize this loss, means we want to minimize our incorrectly classified point and want to maximize our correctly classified point. If we write down just in mathematical form, we want to minimize this our loss and always maximize our profit. This is the main objective of any optimization problem. This is the main goal of any kind of classifications. Yeah, simple if you call it as a optimization problem. So if we just visualize this concept in mathematically plot, just visualize graphically this concept. So in x-axis suppose we called our zi means what? Zi means yi w transpose xi. This is our sign distance. We just take it as our x coordinate and simply y coordinate with our loss function. Take loss function. Okay, so now in other language, if we write down it, both the same. Okay, I think it till now we have no problem. So we want to minimize our incorrectly classified point. What is the minimum number of incorrectly classified? If we want to minimize our incorrectly classified is equals to 0, then we can say our data is 100% correctly classified. So what if our, that is, if zeta is positive, we already know what, if zeta is positive, that is greater than 0, then we can say it is correctly classified. Means we have no, if you forget this about the zeta, then just I request you please go to the lecture number 1 of this series, then you can find it. So if zeta greater than 0, then what? Then our data point is correctly classified. Data is correctly classified. Another language, if we call zeta is less than 0, then what? Then our data is incorrectly classified. So we want to correctly classified means 0. Okay, correctly, yeah, what we have taken in our loss function. Last one means our correct incorrectly classified data points, and 0 means our classifier is equals to correctly classified. So if positive, then our loss functions will be 0. So simple, just write, just I think it better take the red color. Just our data is correctly classified means 0, that is in positive directions it is 0. Is our loss functions takes the value 0. Just see this concept graphically. If it is correctly classified, then zi that is greater than 0. If it is zeta greater than 0, then our loss function takes the value 0. If we take it 1, if it is negative, that is our data is incorrectly classified. When incorrectly classified, then the loss functions taken the value +1. So simply here this side. Okay. So this region is called the positive region, this region is called the negative region. This is the positive region, this is the negative region. Okay, this kind of function, okay, this functions is called the loss function, 0, 1 loss function. Okay, this function, in another language we call it, this is 0, 1 loss function. Just write it down. Loss function in another language it will 0, 1. Loss function. There are many kind of loss functions, but as an example here we have, just for purpose of understanding, we have taken here 0, 1 loss function. Okay, we see everything step by step. Okay, so in ideal case, if we write down this concept in mathematically, what do we write? So we have to find this W star, where W star is all our minimum over all W summation I is equals to 1 to n. What is here? What is our functions? We want to just optimize this thing. So this function we have to optimize, means we have to optimize that minimum, that this is our actually correctly classified situations. We want to that our data points maintain this concept, means we have to find such W that the data points minimize this, that is the error of this function will be minimized. So what? So the language, if you call it the 0, 1, minimize the 0, 1 loss functions. So what is the input here? Input is actually zi, means so what, xi as well as yi and w. 3 arguments are there. Okay, this is so what is the main, now the concept is what is the mathematical equations of these functions. If you can see that it is geometrically, now we want to write it as mathematically. What will be the mathematics functions? So just think a minute, you can find it. So 0, 1 loss functions, if we write it as mathematically, zero one functions, it is 1 when this function is zi is negative, if our zi is less than 0, and 0 if our zi is greater than 0. Okay, if zi our 1, when it takes 1, if zi our less than 0, simply zi is greater than 0. This is simple, the loss function, 0, 1 loss function. So if you have already learned the mathematics in your 12th standard, so I think all are differentiations. So solving the optimization problem, the differentiation, and is the main thing. Okay, so if you want to solve any mathematical optimization problem, then simply calculus, that is differentiation, is the main thing. Yeah, I think you all learn this concept in 12th standard. So solve the optimization differential problem. main concept is differentiation. Which we learn in calculus. Okay, so I think we will learn it in the next chapter. Our next chapter we will learn it. Okay, don't worry about it, we will learn it, everything in next chapter. So now the concept is, if we want to minimize it, simply we have to differentiate it. So now the question is that fx, here fx is what? Here fx is our simple 0 1 loss functions. So just in general case we can write it as fx. So the question is, each this fx is differentiable. Is this differentiable? Is this the big question mark? Is this differentiable? So one concept I think you will learn about the Q12 standard. If any function will be differentiable when it is continuous. Simple. Any function is differentiable, then it must be continuous. Continuous functions. But if you see this function geometrically, at that point, that is 0 they have not defined. Just see it. If it is less than 1, then it takes the value 1. If zeta is less than 0, then it takes the value 1, and if it is greater than 0, then it takes the value 0. But here is not defined any value in 0. If zeta is equals to 0, there have no any defined value. So we cannot say this function is our a continuous function. So simply our 0 1 loss functions is a non-continuous function. Here 0 1 loss function is not continuous. So since it is not continuous, then we have sure that it is not also differentiable. Okay, simple. Now just let's see what kind of logistic log functions are appearing. Just I have changed the window. I am seeing, go to the Google. Just you can go to Google, then just simple type logistic loss functions, and then you can find this picture. Just I am searching it in Google Images. You just go to the Google and search it, and you can find various kind of logistic log functions. So here you can see they have the 4 functions. These functions, that is this function is called, already we have learned that this function is called our 0 1 logistic loss function. 0 1 logistic loss function, and this function, it is that is our black color functions. It is the logistic loss function. This is the logistic loss functions, and there are various kind of functions. That is in red color, is called the hinge loss functions. Okay, this function is called the hinge loss function, and the green one is called the exponential loss function. Okay, there are various kind of loss functions. It is depends on what is your situations and where we have to apply it. So just don't be confused about these kind of things. So now the main things, here we have applied the logistic log function in logistic regression, logistic log function in logistic regression. So now the main thing is that what is the mathematical equations of it. Just you can find, if you search any Google, any internet source, or any logistic regression primary book, then you can find the logistic the equations of the logistic functions is nothing, just is log of 1 plus exp of minus zi. This is our logistic loss functions. Okay, now if you see the loss functions, why, now the concept is why we have taken the fx at the logistic loss functions as loss function as logistic loss functions. So simple, here we have seen in the positive side, just change the color. In the positive side, if you see, this is our positive side, the plane, and this is our negative side of the plane. In positive sides, our 0 1 loss functions takes the value 0, and in negative side it takes the value 1. But because of it is not a continuous function, we cannot differentiate it. So to avoid this kind of problem, we have assumed the functions this when it takes in the positive negative it is positive side. When it takes the value in positive direction, then it tends to 0. Then this value is tends to 0. Okay, or in negative direction, you can think this value is increasing. Okay, this value is increasing. That is not tending to 0. It is, I think it is tending to plus infinity with some numbers. Okay, plus infinity. Okay, this is but this is a continuous function. The main thing is this is a continuous function. Okay, but similarly this kind of function, this is the exponential functions and hinge loss functions. So we have learned all the functions about all the functions, but just patient with it. Now in the logistic regressions, we have taken the logistic loss function. This is our simple logistic loss function. Okay, or simply if we just write down these equations in simple I'm already typing in Google plot this function. Simple, I am writing these equations. If you want to plot this function, then you can see the characteristics of these functions. If it is the positive value, it is the positive. If we take this direction, is our z directions. If we take the positive value, then it is at the time the z increases positively, false positive, then its value tends to negative. Okay, and if z tends to negative, then its value increase to plus. Okay. This is the main characteristic of this function. So simply, if we just go to our main notepad. Okay. So simply, if we just changing the loss functions, they can simply just what is our mathematical application. Here we have simple taking the 0 1 loss functions. So by simply changing our loss functions, we have just find our mathematical optimization problem of our classification. So at the time to time, we have to depend on what kind of data set we have used. So depending on the data set, depending on our situations, we have to choose our loss functions. So simple changing the loss functions, we have assumed we have simple change our mathematical model. So this is the main advantage of our logistic loss minimization interpretations. By changing simple loss functions, we have to change our model dramatically. So if we just summarize this loss minimization interpretations, then simply I can tell that if we just summarize our loss minimization interpretation, then at a single language, if we call loss function minimization, simply loss function minimization. We want to choose a loss functions, just we have to minimize this, then simple our model is ready. Minimizations. So there have many various kind of minimization loss functions. So in logistic regressions, we have used logistic loss. That is used in logistic regression. If we use the hinge loss, then we can build the SVM, that is support vector machine. By simply taking our hinge loss, we can build this SVM, support vector machine. And if we consider our exponential loss, then you can easily build the ADA boost optimization model. Simply if we take the square loss functions, then we can build our linear regression. Okay, so simple, you can see how easy it is. By simple logistic function, loss function, by simple changing the loss functions, we can changing our model easily. So easy this thing. So I think this lecture all about clear how the loss minimization interpretation is important to world of classification, how much important it is. So time to time, we according to the situations, according to our data sets, we have to choose the loss minimization functions. Simply by changing simply a loss minimization function, we can build our new model as our requirement. So I think all the things are clear. If you have any doubt, please comment below. Okay, thank you.